All right, folks, let's go ahead and get started. Welcome to the June 3rd Thursday Web Forum for SECAS, the Southeast Conservation Adaptation Strategy. We host this webinar on the third Thursday of every month right here at 10 a.m. Eastern Time as an opportunity for staff to share the latest updates on the blueprint, get input and involvement from folks like y'all, and share exciting science and action in the world of landscape conservation in the Southeast and Caribbean. So here's our agenda for today. I'll start out by introducing our speakers. They'll present for 30 to 40 minutes on our monthly topic. We'll have question and answer session and discussion at the end. And then I'll wrap up by previewing next month's webinar and sharing a quick update from your SECAS staff. Any questions or comments? We are recording this web forum just as an option for those one or two folks who wanted to attend but had a conflict. I will link the slides and video from the calendar event on the SECAS website within a couple of days. Anyone have anything they want to ask before we get rolling here? All right, not hearing any, I'll go ahead and introduce our speakers. We're going to be hearing from Lauren Berry, who's a graduate research assistant with the University of Arkansas, as well as Caleb Roberts, who's the unit lead for the Arkansas Cooperative Fish and Wildlife Research Unit, which is a partnership between the university and the U.S. Geological Survey. They're going to be presenting on tools and metrics to map and track core grassland habitats and manage how they respond to management or measure how they respond to management. We know that grasslands are an imperiled ecosystem in our region. Actually, the SECAS goal report has shown since the very first one was released that grassland birds are actually the most off track to achieve the SECAS goal. So grasslands have been a major point of emphasis for SECAS over the last several years, and we're excited to hear about some emerging research in this space. So Caleb, I believe we're going to start things off, so you're welcome to share your slides and take it away.
Thanks, Hillary. All right, so just a second here, I'll start off and provide some background on the research that we've done in the past, and then Lauren's going to talk about the amazing work she did when she was doing her graduate work, and then I'll wrap it up at the end. And we'll be happy to take questions after that. So, yeah, this is the title of our talk. I have to, since I'm USGS, I have to have this obligatory disclaimer here. Okay, so yeah, the grasslands of the globe and of the United States are dealing with lots and lots of different change drivers, right? Altered fire regimes, woody plant encroachment, climate change, energy development, urbanization, agriculture. And one of the biggest drivers of change in all of these is woody plant encroachment, right? And these things can lead to regime shifts. A regime shift is a concept in resilience theory that says a ecosystem can have enough disturbance or perturbations, either they are large enough or novel or more frequent than historically, and that can reduce the resilience of that regime, maybe a grassland, and shift it into another regime, usually that's undesirable, like a woodland. The problem with this is these shifts can be difficult to reverse, right? There's a phenomenon called hysteresis, which the input that you have to use to restore the regime is harder than what it actually took to push over to the edge. So you don't want it to happen for multiple reasons, right? And this woody plant encroachment issue and all these other drivers are causing large regime shifts in the North American grasslands. And you can see this in the infamous Rosenberg et al. Paper, right? 3 billion birds lost. What was the gild that lost the most birds? Grassland birds. So I hope that we can sort of agree that there's a huge grassland problem, like Hillary mentioned, that grassland birds and other grassland-dependent biota are in peril, right? And if we want to restore and conserve grasslands, we need to understand the scope and scale of the challenges and meet the challenges with strategies that scale. So that's kind of the motivation for the talk. The thing that we're going to talk about first is I'm going to convince you even more that there is a challenge with the woody plant encroachment regime shift. That we're going to move on to what is a strategy that can actually help us coordinate against, combat this woody plant encroachment problem. That's the finding and defending the course idea. And I'm going to focus on the Great Plains because that's where I've done a lot of my historical research and where we first started testing these ideas. But Lauren's work was talking about how we can move this into the southeast. So we'll explore that, and then we'll wrap up with what we've learned. Okay, so the challenge, as I mentioned, is this idea of a regime shift. So what you're seeing down here in this bottom panoramic photo is this area called the Les Canyons of Nebraska. That was historically, all that was grass historically. Maybe in the draws there would be a few eastern red cedars, but now from a combination of tree planting by people, birds, defecating seeds out, altered fire regimes, and climate change, this is the result of what's going on, right? It's not good for grasslands. The trees are literally, shading out the grasses, and they can't persist. So there's this idea a way to communicate this is this idea of a green glacier, right? And that's a way people have been conceptualizing this regime shift from grasslands to woodlands. And I know this is the West. If we're sitting in Fayetteville, Arkansas, which is, Oklahoma's right there, we're just in the 30 miles to the east of that farthest north part of Oklahoma. But woodlands are increasing quite a lot. This is a paper we put out in 2022 in Journal of Applied Ecology. You can see all the darker green areas. That's where woodlands have increased since 1986, right? Pretty bad. It's a huge problem, and you'll see in a second that's not. It's different, as in, we didn't have the expansive grasslands like the Great Plains did historically, but we did have grasslands. And this example, for instance, from our neck of the woods, glades, which are areas that historically had few trees or no trees, thin soils, had some, sort of arid or prairie-like plants and critters, have now become encroached because of all the problems I already mentioned. And if you don't believe me, maybe, because of a lot of this stuff happened in the course of some of our lifetimes or before our lifetimes. So I'm going to go through the ABCs of woody plant encroachment in Arkansas. That's what I like to call it. The data I'm using for this and most of the remote sensing stuff in this talk, and same with Lauren, is from the Rangeland Analysis platform. Y'all can look that up later. But what we did was we took the data from the Rangeland Analysis platform, and we just looked at tree cover change because it gives you subpixel percent vegetation functional group cover, which one of those is tree cover, from 1986 onward to 2023, and they update it every year. And we looked at all the wildlife management areas in Arkansas and said, what is the tree cover change over time? Okay, so there's no A WMA in Arkansas, unfortunately, but we can start with B, the Buffalo River, C, Camp Robinson, D, DeParty Creek, E, Ethel, F, Fort Chaffee, G, Gulf Mountain. I could keep on going. I could keep on going through every letter of every WMA that they have, and you will see that all except for maybe one or two have a large amount of tree cover increase over time, right? Some by more than double, some not that much, but it's a phenomenon that's everywhere. We are seeing more trees than we saw in 1986, quite a lot more. And so grasslands are suffering because of that, So how can we deal with that? That's where this strategy comes in, this finding and defending core. Before we get to that, sorry, I've got to give you a little crash course on where we came up with this idea, this idea of spatial regimes theory. So we already talked about the resilience theory and the idea of regime shifts from grassland to woodlands. But these phenomena are often thought about in time, right? That something's happening over time in a specific location. But it's also a spatial phenomenon, right? Those trees have to come from somewhere. For instance, a front of birds moving across the landscape and defecating seeds, slowly move them forward, wind moving the seeds, people moving the seeds, et cetera, et cetera. So we came up with this idea of a spatial regime shift, or monitoring spatial regimes, right? So these boundaries between one regime, maybe grasslands, and another, woodlands. We kind of piloted this idea using bird data in our 2019 paper. And if you look at this graphic of the Great Plains outline, you see these 3 bars here. We used breeding bird survey data, and we identified, using some methods you can read about in the paper, these are 3 regimes of birds in the Great Plains, right? The different colors are the different regimes. And we tracked where those were moving over time, north to south. And what we found was that these bird regimes moved northward over 500 kilometers within 46 years. That's pretty depressing, right? There's all kinds of reasons why that's probably happening. Climate change is probably one of them, but woody plant encroachment is definitely another one. But the more important part of this is that these regime shifts are not chaotic in space, right? They are highly orderly across the large scales. And so we thought to ourselves, well, if this is happening with birds, they are probably responding to things that's happening on the ground, right? It's not just happening in a vacuum, right? These grassland birds, they hate trees. That's very well documented. Some of them are more or less tolerant to trees, but by and large, if there are a certain amount of trees on the landscape, these grassland birds just will not be there, right? So we came up with this idea of, like, if the grassland birds are this regime of birds is moving, well, there probably is a shift in the vegetation, right? That's not a profound thought, but we need to find a way to track it. So we used the rangeland analysis platform, and we came up with this idea. Dan Uden et al. Came up with this idea of spatial covariance. Okay, so the nice thing about the rangeland analysis platform is that every pixel, like I said, has a percent cover of a vegetation, a functional group. And so you can see, for instance, what's the percent cover of trees and the percent cover of perennial forbs and grass, like native warm season grasses, right? And if you calculate spatial covariance on those two different functional groups in a moving window, you can get a boundary of where trees versus grasses are in space, right? So you can literally map by pixel, where is this boundary between trees and grass, and how strong is it, and how far away is it, and things like that. So a very negative spatial covariance is a boundary. Near zero spatial covariance is intact something, probably grasslands in our context. And then a positive spatial covariance is not super interesting. It means coexistence between trees and grass. That doesn't come up as much because, on some level, trees and grass cannot coexist, right? And like to if you think of it at large scales, because the trees literally shade out the grass, right? I'll mention the Sentinel-2 dynamic world stuff because in the Southeast, we had to adapt this protocol because a lot of our areas are flooded seasonally, right? So we had to mask out the flooded areas. That's sort of a lesser important part, but I'll just mention it there. So what does the spatial covariance tool look like? Looks like this, okay? So this is an aerial image of a boundary between trees and grasslands, right? And then on the image B, the panel B, you're seeing what the spatial covariance looks like. So the red areas is the boundary that I talked about. It's showing you where the boundary is. And then the blue area is this intact core area. Now you'll notice that it's on both sides of the line because it actually does sort of pick up on, is it intact woodland or is it intact prairie? It doesn't really distinguish that, but we can tell from the context which one's which. Okay, so if we play this out over a landscape, this is a hypothetical situation in the West Canyons of Nebraska, this map here. You can track how these boundaries are moving across the landscape, right? So you can see where are the trees moving or are they not moving, and make your prescriptions for management based on that, which we'll talk about in just a second. So this I'll mention here that the idea behind this again is preventing the regime shifts, which is maybe a different way of thinking about it than we have historically. Historically, we would find a place that was very bad, right? A very degraded state, maybe a highly infested wood or former grassland, and do a ton of management on that to try to knock it back to grassland. Well, that's very expensive. It's reactive and has low success because of hysteresis. I just talked about that. There's a seed bank of trees. There's probably trees all around the area. The soils are probably changed because of the trees. It's predisposed to go back to a forest very quickly. If you have an area that was a remnant or a core and you work only on defending that and then building outward from that, the idea behind all this is that will work better as far as getting you results, and it's less expensive and it's higher success, okay? That's this idea of finding and defending the core. And by the way, we'll talk about this later at the end, but this was, developed, this figure And some of these ideas were developed also by Working Ranch for Wildlife in the NRCS. And so they're already being enacted out west. So what happens if you don't follow this idea of defending the core versus if you do? Well, I'm going to tell you the tale of two prairies here a little bit. One that didn't follow it and one that did, okay? We'll start with the didn't because I get the negative out of the way first. Fort Riley, Kansas. We put a paper out in 2022 in Ecological Applications. Showed in Fort Riley, which is Army base, right? Historically, tallgrass prairie was unplowed. There's still a lot of prairie there. But you can see in these mapped images that the woody plant encroachment, all the reddish stuff, is moving in. It's starting to strangle the life out of the intact core grasslands, which is affecting grassland birds, right? Like greater prairie chickens. They have some really cool LEC data that we used for greater prairie chickens. We found that as the woody boundaries are closing in, that's highly correlated with LEC occupancy. So basically, the areas that they can use to LEC are just shrinking. They're getting strangled out. And if you put it another way, there is a level where greater prairie chickens, represented by this black line, just will not LEC in a place anymore, based on what the woody boundary strength, right? This idea of spatial covariance is. And if it goes below that, they're just not going to be there. And we're tracking the fact that it's getting to that place, right? That's not a good signal. So they have a core, and I'm not trying to throw shade on Fort Riley. They are doing good, and we did stop our analysis in 2017. I think that I've heard that they've done quite a lot to reverse some of this stuff. So, this is just historically, from several years ago, what was going on. But this is an example of what could happen, right? But from a more positive perspective, we moved to the Les Canyons in Nebraska. I've talked about them. What we found from a study with Dr. Dylan Fogarty is that by using this defend the core idea, what they did was they weren't able to reverse the tree cover, and at this point, at least when we did the analysis, but they have been able to halt the tree cover expansion, right? So it was going up, and then it leveled off. That's what they've been able to do thus far. And if you want a visual on that, this is spatial covariance again, 2000, 2005, 2010, it's not looking good. But then, right, something's happening. They're starting to turn back the tide a little bit. And it's because what they did was they are able to do massive, very intense fires out there. This is all private lands. They can do whatever they want, right? That they make these 1,000-acre fires. They're very hot. They're killing trees. And where are they putting them? They're putting them in the places where the core is intact and they can defend where they've got and push back against the rest, right? That's what these black polygons are showing. And what's the result of that? So they did decrease tree cover, leveled it off. They have gotten biomass back. I can't show you that right now because I don't have time. But one of the things I can show you is a paper that we published a few years ago that shows one of the biggest success stories of grassland bird restoration for richness in the private lands ecoregion that we know of, okay? What we found was areas that, or for the biggest headliner that we found is that grassland bird richness increased across 90,000 hectares of this ecoregion. This ecoregion is 136-ish thousand hectares. That's a lot of hectares to have this kind of success on. You don't hear about that kind of success for grassland birds very often, right? That's a huge thing. And where did they increase? They increased where the areas, of course, where they treated with fire and restored back to grasslands. But more importantly, in some ways, they increased where the woody cover was already low. Okay, so what I'm saying is they increased in areas where they defended the core and where they pushed out against from the core out into out into the invaded area. So what about the southeast, right? This is where I'm going to hand it off to Lauren, and she can talk about what we found because maybe you're telling yourself, well, the Great Plains are quite different from us, and maybe these results don't apply to us. Well, Lauren's going to hopefully dispel that little myth for you. So I'll hand it over to Lauren now.
So this is my master's work. I defended it back in April. And so we took some of these methods that Caleb just talked about and, like he said, applied them in the Southeast. As we know, grasslands of the Southeast are a lot more fragmented, they're wetter, and they're just less vast and arid than what we think of when we think of like the Great Plains or rangelands of the West. And so for our purposes, it was important to see how this covariance and boundary detection metric applies in these grasslands that are fragmented on a smaller scale. So our objective here was to determine grassland bird community responses to spatial covariance. So this is a figure that Caleb showed. And what we expect here is that grassland birds, like what he showed with the greater prairie chicken-lecs, will be less likely to occupy these areas with negative spatial covariance. So these red areas that are highlighting this boundary between grasses and trees, we expect that even in the southeast, grassland birds will be less likely to occupy those areas. They'll be more likely to occupy areas with zero spatial covariance. And like Caleb talked about, this paper came out in 2019, Rosenberg et al., and it documents the decline of the North American avifauna, but again, which guild of birds is suffering the highest magnitude of population loss? Grassland birds. So that poses the question of how are grassland birds responding to woody plant encroachment that's driving the global decline of grasslands. And so this is a figure from the Cornell lab that A, is just really beautiful, but B, kind of shows how woody plant encroachment affects grassland bird communities. And so we have an intact grassland on the left with our familiar grassland birds. And then if a tree is introduced, a woody plant, just one, we'll still probably see most of those grassland species that we know and love. But eventually that tree will seed disperse, and typically with up to about 200 yards from the original tree. And then we move into what is an encroached grassland and then eventually a woodland. And we lose the grassland bird diversity. So it's not that all birds are disappearing, it's just that grassland birds are going to be less likely to occupy those areas. And so in order to understand the effects of grassland, or the effects of spatial covariance on grassland birds, first we need bird data. So my field techs and I collected data, point count data at 5 sites across the Arkansas River Valley and the Mississippi Alluvial Valley in central and east Arkansas. And so these sites were some national wildlife refuges and then 1 wildlife management area. And I've highlighted one of our study sites. This is a restored grassland at Cache River National Wildlife Refuge. And I've inputted both the aerial imagery, just the basic satellite imagery, and then what it looks like when we overlay the spatial covariance calculations. So you can see that where there are boundaries between that restored grassland and then kind of the woody encroached areas around it, you can see that it's picking up on these boundaries, and those boundaries are being highlighted in red, whereas it's pretty blue throughout contiguous grassland. Another cool thing to pull out here is that there's kind of this like wetter area in the northeast corner of this, or I guess in the central part of this grassland too, which you might not know just from like aerial imagery, but we know that it's wet and kind of swampy from trudging around in there. And it's interesting to see that the spatial covariance layer is pulling out also that distinction. And so we used these 6 birds for our model, and we did a multi-species occupancy model. So multi-species occupancy models do, they calculate single species occupancy probability and then also a community occupancy probability. And these are the birds we used. They're all grassland obligate birds that appear in our study site. And these are the results. And so this is showing us that all grassland birds that we modeled have a positive relationship with spatial covariance. So if spatial covariance is nearing 0, their occupancy probability is going up. And you can also see that on the bottom for the community, the grassland bird community as a whole, well, based on these 6 species, again, a positive relationship with spatial covariance. And these are marginal effects plots for all 6 of the birds that we modeled. And so all of them, you can see the strength of the relationship is idiosyncratic across the bird species that we modeled, but all of them increase in occupancy probability as spatial covariance nears 0. And so again, a 0 spatial covariance is going to be kind of that contiguous land cover, whereas a strongly negative spatial covariance is going to represent a boundary. We were also able to map the occupancy probability across an area. So I'm zooming us back into that area at Cache River National Wildlife Refuge with the restored grassland and kind of a wetter area in the middle there. And this is the mean grassland bird community occupancy probability. And so we can break this down by species, but for the purpose of this little talk, I've just included the community occupancy map. But you can see that they have higher occupancy probability in these strongly blue areas or 0 spatial covariance areas. And the occupancy probability is lower, the occupancy map is darker, where there's kind of this wet spot in the middle of the restored grassland, and spatial covariance is indicating that there's a boundary there, and also a lower occupancy probability near the boundary on the east side of this restored grassland. So I'm going to toss it back to Caleb here.
Okay. Yeah, great job, Lauren. It's really exciting to see us being able to do this. I'll mention that was part of a science support partnership grant through the Fish and Wildlife Service. So thanks all of Fish and Wildlife Service people for supporting that. So yeah, what have we learned from this process? You can advance, please.
Oh, yeah.
Well, for one, I mentioned this earlier, and we'll come back to it here. The working lands for wildlife, the western half of that body is already using this idea for two grassland biome scale conservation frameworks, right? The Great Plains biome and the sagebrush biome. So this isn't just something that we're blowing smoke about. They're already using it to strategize their management at very large scales. And the hope is that if we keep on doing a few more tests on this, we can hopefully push this into the southeast a little bit to help us strategize out down here. Okay, you can advance, please. This is just another example of what some of y'all might be more familiar with for how they're using this in the biome scale frameworks. Please advance. But I would say, the proof is in the pudding. I think it's a fair caveat to say that we haven't directly tested this strategy, except we've observed the outcomes of it, right? So we haven't had some sort of before or after control impact study, but what we can say is that an area, the Les Canyons, for instance, that did use this defend the core strategy has seen an enormous success, right? So I showed you grassland bird richness, but if we use breeding bird survey data and look at relative abundance, for instance, of quail, everybody loves quail, right? We've found that since the time where that dotted red line is when they started using this idea of defend the core, there's been a 236% increase in relative bobwhite abundance. That's a huge success, right? And advance, please. And if you look at the map of where quail are in the Great Plains, that's the Les Canyons right there. They are a light, right? There's a few places that have done just as well as they have, or maybe a little bit better, but there aren't many. And I'd be interested to see what kind of strategies they're using. So you can advance. I think it's the last one. Yep, and there it is. So thank you for your time. There's our contact information, and happy to answer questions. You can just either Lauren or I are happy to. I'm gonna say Lauren is so.
Well, thanks y'all so much. That's an amazing presentation, some really exciting research, and yeah, those metrics of success are really inspiring, frankly, to see the difference that this is making on the ground. We have plenty of time for questions. Thanks y'all for sticking to the time so well. So please feel free to take yourself off mute or drop a question into the chat if you have one. Yeah, go for it, Rua.
I was giving other folks a chance to ask questions. I didn't want to jump right in.
Get us started.
Yeah. So this is awesome. This is awesome stuff, and it's just definitely like a nice handshake between, like you mentioned, the sagebrush stuff fits with the Central Grasslands kind of initiative idea of that sort of defend the core component. This isn't a question, but more of a statement. Tried some of this work farther east, and especially where you have a lot more savanna dominated kind of grassland systems, and it sort of starts breaking down on the boundary side, because I feel like there's this sort of handshake in grasslands where it's like you have bigger, completely open grasslands, and as you go farther east, you have more of that matrix, and even quail are using a mixed set of, they're using longleaf pine, they're using adjacent habitats, they're using scrub shrub. And it seems like, I think the concept is still sound about the defending the core part. It's just, seems like it's a little bit trickier spatial quantitative methods to to get at those cores, and of having to use a lot more different kind of things beyond just the spatial covariance side. But I think it's a great thing in the toolkit for figuring it out and making that transitional handshake. Definitely the tree savannas that are stable savannas. I mean, longleaf pine's a great example of that, where it's like trees and grass coexisting over the long term and where they're supposed to be. And it definitely throws a fun curveball as you go further and farther east into the equation.
Yeah, that's definitely a fair point, Rua. I would say, one of Lauren's sites, we didn't have time to get into the specific sites, but Lauren maybe could have more of a better description of this. But one of her sites essentially was a savanna, right? That's what I'm thinking of, and they have maintained it like that for quite a while. I would say, visually, you're right. I would say that if you were just thinking about looking at the metric, it's more about dialing it in, I would say, because metric works. That was baked into all of Lauren's models as far as the grassland bird response, and so I would say that it won't visually sort of look the same, of course. Or I mean, I'm thinking remote sensing, but on the ground, of course, it also will not look the same as out west. The idea, like you said, is still there, and the idea of this is a regime that it's stable in the long term, moving around in the short term on the landscape of where trees are and where they're not. But once I'm thinking of once it gets up to turkey oak or something, right? Then we've got the regime shift, right? It's musified, can't hold fire as well. There's just nothing to come back from. Maybe after so many years, there's the seed bank's gone or something. I'm not as much of at all as an expert on those areas, but I know that there's still definitely a place for this. I think, and it's just how do we calibrate it to the south, those specific ecosystems in the southeast.
Exactly, that's happening. The regimes are existing out there. It's just how do we get the spatial components of it. And I'm sure there's also variations even out west and related to quality and other things that we just can't sense, especially as you get down to Texas and Oklahoma, and things look more and more the same, even with the range map data. It's like, oh no, same green up, same time periods. But yeah, I think it's the concept though. The concept of the cores, the concept of the regime, obviously is solid and applies everywhere.
Yeah, thanks for that, Rua. Very interesting discussion. I mean, what do we always say? Anytime we try to draw a line, nature's I'm going to have an exception to that line, or a weird hybrid between that line. We have a question from Brian Hummel in the chat. Are you working with agricultural producers to improve bird habitat? Have you looked at the RCPP grants for protecting these core habitats? And if y'all aren't maybe as involved with kind of the on-the-ground restoration, are any of the partners you're working with, maybe conservation delivery specialists with the JVs, or if you just want to speak to that at all, that would be welcome.
Yeah, well, I will Yes, yeah. So we haven't yet, or actually, well, I should say we are just starting to. I'm in conversation with our private lands division at Arkansas Game and Fish they are doing they have an open pine RCPP out right now, and I think they're trying to do another one. So it's in sort of South Arkansas, northern Louisiana, and I really want to move this sort of stuff into those fields, the private lands field, and that's what it was out west. So there's a lot of experience with the messaging and with the visualization for that. So I'm really excited to do that, and I really do see that is the next step for this, because where our grasslands mostly, they're on working lands, even out in the southeast, right? So.
Very cool. Thanks for that question, Brian. Anybody else want to jump in? We have plenty of time.
I have a question for Lauren. Because Lauren did a lot of really good work with Game and Fish and Fish and Wildlife Service. I'm thinking of like Clint Johnson at Camp Robinson. Lauren, what was when Clint asked you for some maps at Camp Robinson? What was his response? Because he literally went out and checked your map spaces, what he drove out there and looked around at, and what were his thoughts?
Well, he said the maps are pretty accurate being on the ground. I'm not mistaken, Camp Robinson is what you were talking about. It's kind of being a savanna, right? But so that's a beautiful, beautiful site that our Game and Fish Commission has really put the effort into managing. And it's kind of like a tester site. They do a lot of test management out there. And yeah, so Clint Johnson is he's the head of that site, and he asked me the occupancy map that I showed. He asked me to send him georeferenced maps of Camp Robinson, and he drove around to see what that actual on the ground habitat looked like, and he said that the maps were pretty consistent with what he was seeing on the ground, and he was excited about it. So that's another possibility too for on the ground management, being able to look at what we derive from the rangeland analysis platform and the covariance calculations. Go actually look and see what that looks like in a unique system.
Here's a question from Jessica Burnett with NASA. How far does Sentinel and Landsat data get you in this effort? Do you use any high resolution imagery?
Yeah, great question, Jessica. Landsat, okay, so there's two levels of this question. We actually did try another metric using Sentinel data. So Sentinel is 10 by 10 meters, Landsat is 30 by 30, right? There was some concern that Landsat would be too coarse given how fragmented some of these grasslands are and small. So we tried both. We weren't successful with some initial tests with the Sentinel data. Clear, all the stuff that Lauren was showing that I've shown is from the rangeland analysis or Landsat. They use the Landsat data for that. So, so the Landsat seems to be working. It would be great to move into a finer resolution like Sentinel. At some point if you're thinking about meter by meter or sub-meter accuracy, that's not really, there probably are applications for it, but I think, on the scale of what, for especially grassland wildlife need, maybe I'm leaning more too much towards birds. There's plant people and bug people out there. I know they exist somewhere. So, but the grassland birds need quite a lot of grassland, and so I think that those resolutions still work for at least those applications.
Yeah, that's an interesting question. I know that's something that we've discussed as a SECAS staff too, that sometimes we're seeing all this amazing groundbreaking work on finer and finer imagery, although to an extent, I think from what I've seen in my work doing user support for the blueprint, 30 meter is generally good enough for most applications. And from where I sit, I feel like for me, it would more be an emphasis on regular updates to 30 meter data or more comprehensive coverage of 30 meter data in the Caribbean and things like that is kind of where I would want to see big data providers moving the needle more than just finer, really trying to, make the coverage as consistent and as regularly updated as possible with the 30-meter stuff that we have. So it's interesting to hear that you already looked into that. Rua, I see your hand.
Yeah, I think I would echo that, and that getting more, regularly updated and improving the classification accuracy of certain things, especially around like grassland categories. That's one of the biggest problems we have of being able to see native warm season grasses versus not native and all that stuff. I do think the only exception, I think, for the fine resolution is once you start getting into savanna ecosystems, because you run into that adventure of canopy cover when you start having 30-meter pixels, that if you had finer resolution, I could see an application and thinking about like the actual condition of the savanna itself, because just, where those 30 meters sit randomly can kind of muck up how well you can capture what that savanna core is. And they're not, homogeneous even within them. But I think that could be a helpful use. But like you were saying, it's really about improving the accuracy, and kind of regular updates of the 30 has been some of the biggest applications with this kind of thing.
Those are good points. I'll point out that the rangeland analysis platform uses Landsat data, but I think a lot of people have been raised up on the national land cover data set because it's a fantastic data set, right? But and it does things that the rangeland analysis platform doesn't do. But what the RAP, they call it, does do is, like I said, it gives you sub-pixel estimates of vegetation functional groups. So every pixel, you'll know it's 30% trees, 20% shrubs, 50% perennial forbs and grass, and I'm probably I don't know if that added 200, but it gives you, it tells you that within a pixel. So there's some issues with that. They do have, as far as like you don't know what it looks like within the pixel, right? You just know the percent covers within the pixel, but that is, and it's every year. It's not every 5 years or whatever the NLCD is. So it's a really neat data set.
That's fantastic. Yeah, I think we used rangeland analysis platform data in the current version of some of our grasslands indicators. I think we're refining that approach a little bit this year for the blueprint. I don't know that we're using the RAP data in this go round, but I know we found utility in it in the past. A couple more questions in the chat. Did you have? Well, actually, I'm sorry. Let me go to Doug Newcomb's hand first, because you've been very patient, Doug. If you want to jump in, and then I'll go to that next question in the chat.
Yeah, I was just wondering, had you looked at the SAR data at all at the 10-meter resolution for Sentinel-1 for your keeping track at a high temporal resolution of changes in vegetation? That's one thing. And the other thing, I was wondering if you looked at fine-scale DEM data or even the intensity data from the ground points for picking up moisture in the terrain as possible vectors of trees going into the grasslands or targeting your burn efforts.
No to the soil moisture. We've never fiddled with that, and not that it's a bad idea. I guess what I'll say about that is, this method, when we wrote the grant, actually, we call it a rapid mapping tool, right? So the idea is that this is supposed to be a quick and somewhat dirty way of finding these cores, right? And then on the ground, people need to be like, oh, this is a degraded fescue prairie or like area, or this is a remnant prairie or something. That's what this thing is good for. It's good for finding them, and then it's good for tracking where the trees are. It can be used, by the way, for if you're looking for annual versus perennial forbs and grasses too. So there's applications, especially out west, for that. But that's what this does, right? It doesn't give you the really specific grassland, what composition of it is. Sentinel, that's a great data set. What we used it for, we used the dynamic world data set, as I mentioned earlier, to mask out flooded areas, right? So in our sites, a lot of these places are flooded up until May or June, right? So we had to cut that out because that's updated every 5 days or so, right? And that's what we use Sentinel for. What we would love to use Sentinel for is making the boundary detection like we did with Landsat with the RAP, right? That's what we were trying to test out, but it at least in our initial tests, it didn't work out. We have some ideas of how to move in the better direction, but that's beyond the scope of what we did with Lauren's project.
Those are interesting ideas, Doug. Thanks for that. A question from Bill Vermillion in the chat. Did you have a minimum grassland area cutoff when you were selecting your study sites?
Oh, no, we didn't. How did we just select the study sites? You can tell that's all on the top of your mind, I'm sure.
All of our study sites were kind of like remnant prairie, I guess, like all interspersed trees and some grassland, but all kind of in the Arkansas Grand Prairie, which is the Arkansas River Valley and the Mississippi Alluvial Valley. All of them are pretty degraded, except that one I mentioned that it's kind of a savanna and they do pretty intensive management on. The others don't undergo super intensive management. And they were all public land.
Yeah, basically, yeah, that's exactly right. And the bigger thing was, given the type of grant this was, it was based on refuges and where the Fish and Wildlife Service in Arkansas was interested in looking at their lands. So I will say that they were in different, like Lauren mentioned, different management areas. So one was like a complete like carte blanche. They like totally nuked it and then replanted, reseeded it, and let some seed bank come back with native prairie. There's that area. Then there's the one Lauren mentioned, the savanna, and then there's the degraded one. So that we tried to do it over it. What we did try to do is a gamut of management types, so we could see, like, is there variation across that?
That makes sense. Well, we've got 5 or 6 minutes left. If there are any other burning questions, or I can move on to some SECAS staff updates, but I want to make sure everyone has time to ask anything that's on their mind. Trying to do better about embracing the awkward silence, making sure people have a chance. Oh, a question from Brian in the chat. Are you familiar with this particular rancher in the Arkansas River Basin who received a Alto Leopold Conservation Award? Looks like a pretty cool project.
Do you know this person, Lauren?
I don't think so. I'm clicking on the link.
Interested in it though. I definitely need
the May Ranch, it looks like. Pretty cool.
Yeah,
oh,
cool.
Maybe a potential future partner.
Yeah, really.
Okay, well, we'll have time to pause again before I totally close this out. So if something occurs to you in the next couple of minutes, feel free to drop it into the chat or just hold on to it for a few minutes. I wanted to let y'all know what to expect from next month's web forum. It'll be same time, same connection information as today. The date is July 18th. And we're going to be hearing from Shan Kamek and Jennifer Fawcett talking about some of the more stringent national ambient air quality standards that have been set by the EPA and what that means for conducting prescribed fire across the Southeast, knowing that smoke obviously can contribute to tripping those regulatory air monitors. And they've been exploring, especially in Georgia, and some work led by Georgia DNR, using these, what are they called? The emergency event designations, where they say, disregard this. This isn't a typical day. We're doing an extra special event here with our prescribed fire. So this is some really amazing collaborative work that's being led by Georgia DNR and the Southeast Regional Partnership for Planning and Sustainability, SURPASS, which is a partnership working Southeast-wide, especially on military mission, private lands, and conservation issues. And I want to hand it over to Rua to give a quick update on some of our progress toward the 2024 SECAS goal report.
Yeah, so it's actually really good timing on this particular meeting, because one of the things we're working on updating in the recent trends in southeastern ecosystems report this year is our grasslands and savannas indicator. And I think Caleb set up the forest encroachment issue really well, and we are basically seeing that very strongly, as you might expect from that setup, just about everywhere in the Southeast. So that's one of the things we're updating, looking at trends in grasslands and savannas across the area. What are they turning into? Where are they going? And so now that we have a new grasslands and savannas indicator covering the full Southeast, we're crunching some numbers. And so we'll probably reach out pretty soon for anyone that wants to be part of a review team to look at kind of the methods we have and what progress, what kind of trends and how we want to synthesize that information, because there's a lot. And I will tell you, as you probably guessed from Caleb's thing, and many of you probably know, the numbers are pretty horrifying, and even recent trends are very horrifying over the last 10 years. So excited about that. And we're making a few other improvements. We've got more high resolution information on bird trends going at state bird conservation region level. So we'll probably be overhauling the bird indicators in there and a bunch of other stuff. So very excited about it. Just a quick teaser, and there'll be more information in the newsletter, and hopefully reach out soon for anyone that's interested in taking a look at some of the trends estimates across the Southeast. We'll keep your ears out for it.
If someone is interested in getting involved in that grassland savanna trend thing, best to email you.
Yeah, that's fine. Yeah, email. Yeah. Go ahead and email me or email Hillary if you don't have my email address. That's fine. However you want to do it. We'll make sure you know about it, and we'll reach out larger folks on the list as well.
Yeah. Okay. Thanks so much. So with that, I would like to end on this slide, how to get more involved in SECAS. You can sign up for our newsletter on the footer of any page of our website, secassoutheast.org, and that'll get you signed up for our monthly newsletter, as well as a reminder email about this monthly web forum. You're, of course, welcome to connect with your SECAS staff or other partners who are involved in the partnership. You can find that information on our website. Of course, we encourage you to explore the Southeast Conservation Blueprint and let us know how it's working for you. If we can help, we have a team of user support folks who are here to help you use the blueprint, whether that's to bring in new funding, inform a decision, or a conservation plan. Please reach out to us and we would be happy to help support you in your work. So with that, I will just pause again and see whether anyone has other questions for me or Rua, or for Caleb and Lauren before we hang up.
Thanks for having us, by the way.
Thank you so much for the great presentation. I really appreciate it. That was super thought-provoking and nice to see some good news sometimes, see that things are working. All right, well, I'm not hearing any, so everybody enjoy, and 5 minutes. We'll end early today, and I will hopefully see you all again in July. Bye, everyone.
Thank y'all.